Air drying is essentially removal of moisture from air. This can be done by different methods, and the choice is based on the degree of dryness required. LNG carriers use a refrigeration dryer in the first stage. This works on the principle of removing the water in the air by condensing it and is capable of handling large volumes of moisture. The secondary stage uses a regenerative system which has adsorbents which can be reactivated. They adsorb moisture due to their molecular affinity to water. The air supplied to the cargo system is dried in two stages. In the first stage, the air is cooled to around 5 degrees centigrade by Freon refrigeration plant, where moisture in the atmosphere is condensed out and drains to the bottom of the heat exchanger. It is designed and rated for continuous operation. Capacity: 350,000 kilocalorie per hour at -2 degrees centigrade evaporating temperature. To cool the air between +35 degrees centigrade, 70% humidity and +5 degrees centigrade 95% humidity. Air inlet filter is made of polyamide fiber. Regeneration drying unit. The second stage consists of a cylindrical tank packed with activated alumina where most of the remaining moisture is removed. The air leaving the drying tower will have a dew point of -25 degrees centigrade with both blowers running or -40 degrees centigrade with one blower running. It is designed and rated for 20 hours operation, after which it must be regenerated. The 20 hours is not a fixed figure and will vary according to the humidity and temperature of the atmospheric air. Capacity 13,500 Newton cubic meter per hour from +5 degrees centigrade. 95% humidity at dew point -25 degrees centigrade and 6,750 Newton cubic meter per hour and dew point -40 degrees centigrade. Regenerating fan is a centrifugal fan rated at 5,500 cubic meter per hour and direct driven at 3,600 revolutions per minute by a 22 kilowatt electric motor. The air is drawn through the first and second stage dryers in series by either both of the blowers, which then discharge through silencers to either the cargo system or to atmosphere. The main dry air blower serves the dry air system. Roots type -6,750 Newton cubic meter per hour at 1.3 bar head and a suction pressure of 0.92 bar. Screw compressor supplies either the dry air system or in an emergency is used to supply air at 2 bar gauge to pressurize one or more water ballast tanks to prevent the ingress of seawater in the event of underwater damage of the hull or to empty flooded ballast tanks after grounding. It is rated at 5,820 Newton cubic meter per hour at a head of 2 bar gauge and with a suction pressure of 1 bar absolute. While drying the cargo tanks, both main blowers will be used initially to lower the dew point of the cargo tanks to -25 degrees centigrade, and then, if required, one blower only will be used to lower the dew point to -40 degrees centigrade. The normal dry air blower is designed to supply 6,750 cubic meter per hour of air at 0.3 bar to the cargo system. The contingency compressor is designed to supply 5,820 cubic meter per hour, so that together up to 12,570 cubic meter per hour of dry air can be supplied to the cargo system. The system is designed to accept atmospheric air at 35 degrees centigrade at 70% relative humidity and process 6,750 cubic meter per hour to a dew point of -40 degrees centigrade or 12,570 cubic meter per hour to a dew point of -25 degrees centigrade, measured at atmospheric pressure 760 mm mercury. The plant is started and stopped manually at the dry air plant control panel in the dry air plant room.